chemical formula. Now, what is chemical formula? It's just the symbolic representation of a compound. Basically, the chemical formula of a compound represents the composition of a molecule of the compound. And that composition, we write that composition in terms of the symbols. That is why it's symbolic representation. Basically, the composition of molecule in terms of symbols of the elements present in it. So that is chemical formula when you represent any compound in a in symbolic form. Now, to write chemical formula, we should learn valencies and radicals first. See, I told you in the previous lecture that we are having two types of ions, simple ions and polyatomic ions. No, simple ion is the one which is made of only one type of atom, that like hydrogen ion, sodium ion, chloride ion, oxide ion. But we are having polyatomic ions as well. Those ions which are formed from groups of joined atoms, like ammonium ion. See, in ammonium ion, we are having two types of atoms joined together, nitrogen and hydrogen. Same carbonate ion, sulfate ion, we are having different types of polyatomic ions. So, to write the chemical formula of any ion, we should first know their valencies and radicals. Radicals are nothing but polyatomic ions. So we should know the valencies of ions, we should know the radicals, then we can write the chemical formula. So here I'm presenting some radicals here and their charges. Hydrogen, you know the formula would be H positive, 1 unit of charge. Sodium, Na positive, again 1 unit of charge. Ammonium does NH4 positive. Chloride ion, that is Cl negative. Or hydroxide, OH negative. Chlorate, ClO3 negative. Bicarbonate ion, that is HCO3 negative. Bisulfate ion, that's HSO4 negative, 1 unit of charge. We are having permanganate, that's MnO4 negative. Barium, Ba2 positive. Now see, barium, it's a simple ion, but this permanganate is a compound ion, it's a radical. Magnesium, Mg2 positive. Cupric, 2 positive, Cu2 positive. Ferrous, Fe2 positive. But yes, cupric and ferrous, basically copper and iron, have other two valencies also, but here I have mentioned only one type of valency here, 2, and for iron it's also 2. Aluminium, 3. Antimony, that is Sb3 positive. Boron, B3 positive. Ferric, Fe3 positive. See, this is ferrous and this is ferric. Here it's 2 positive, it's 3 positive. Phosphate, this is polyatomic ion, PO4, 3 negative. That means 3 is its valency, 3 is the charge. Whatever is the charge of an ion, that is also the valency of an ion. So basically here charge is 3, so valency is also 3. Here charge is 3, valence is also 3. Here in nitride charge is 3, valence is also 3. So basically valency and charge are the same in case of ions. Now, how can we write the chemical formula of different compounds? See, we are having different compounds like water, sodium chloride, magnesium oxide. We are having their formula like for water it's H2O, for sodium chloride it's NaCl, for magnesium oxide it's MgO. So we are having different formulas for different compounds. Now, how can we write different formulas for these compounds? Why we write H2O for water? Why not OH2? So there are basically some rules as per we are writing the formula of different compounds. So the compound which is made of only two elements, that is called a binary compound. Here you can see water is made of only two elements, hydrogen, oxygen. So it's a binary compound. Sodium chloride is also made of two elements, sodium and chlorine. So it's also a binary compound. Now, if we know the valency of the elements that are present in a compound by which a compound is formed, if we know the valencies of the elements, then we can work out the formula of their compounds by balancing the valencies of different atoms which occur in the compound. That means the first thing you have to do is to balance the valency or charge. Valency or the charge on ion must be balanced. That is the first thing we need to do, but we can only do that thing if we know the valency of elements. So for that we need to remember the valencies of elements, whether it is single element or the compound. So Uh, For instance, we are having H2O. How can we write this formula H2O? So first of all, we should know the valency of hydrogen and oxygen. So valency of hydrogen is 1 and valency of oxygen is 2. Basically, we need to adjust the valencies of hydrogen atom and the oxygen atom in such a way that the total valency of hydrogen atom should become equal to the total valency of oxygen atom. Now see how we'll give the correct formula of this compound. So valency of hydrogen is 1 and valency of oxygen is 2. Now see, the valency of oxygen is 2. That means we need to balance this valency of 2 of oxygen atom, right? So we need to have 2 atoms of hydrogen so that this 2 of oxygen will get balanced. So basically we need 2 atoms of hydrogen. This means that 2 atoms of hydrogen will combine with the 1 atom of oxygen, right? So we need 2 atoms of hydrogen, then they get combined to the 2 atoms of oxygen to get the formula of H2O. So when valency of hydrogen becomes 2, we need to balance this. So this 2 will go to hydrogen. So it will become H2 and 1 will go for oxygen. So it will become 1. So 1 atom of oxygen and 2 atoms of hydrogen are combining. And the number of atoms are always written in the subscript. So here 2 atoms of hydrogen will combine with the 1 atom of oxygen and they form the compound H2O. That is the formula for water. That is the formula for water. Okay. So this is the basic thing we need to do. First, write the symbols of the element which form the compound. Then below the symbol, write down their valencies. And then what you need to do, cross over the valencies. That means this 2 will go to hydrogen and this 1 will go to oxygen. And that is how you can write the formula. And yes, number of atoms should be written in the subscript. Now the next thing we need to do is that whenever an ionic compound is formed, we know that ionic compound is basically the combination between metals and non-metals. So while writing the formula of an ionic compound, the metal is always written on the left hand side. That means metal symbol is always written first, and the non-metal element is written on the right hand side. That means later, after the metal. So see here, that is why we have written calcium oxide, not we have written CaO, not OCa, because calcium and oxygen, here calcium is a metal and oxygen is a non-metal, and metals and non-metals form an ionic compound. So basically this is an ionic compound. So we need to write metals first. So that is why calcium is written first, symbol of calcium, and then the symbol of oxygen is written. That is why it's not written as OCa, it's written as CaO. Same goes with sodium chloride. Sodium is a metal and chlorine is non-metal, so sodium needs to be written first. So Na is written first, then chlorine, then Cl. Same goes for water. That is why it's not OH2, it's always written as H2O, because metals come first, then non-metals. And yes, the metal element is written as such, like it's calcium oxide, so calcium is written as such. But the non-metal element is the name of the non-metal element is changed to have the ending IDE. That means here oxygen becomes oxide, IDE. Chlorine becomes chloride. Sulfur becomes sulfide. So whatever be the non-metal, whenever you are having ionic compound, name of a non-metal is changed and have the ending of IDE. Okay. Now the next thing is, whenever you are having a compound in which there is a polyatomic ion, then that polyatomic ion is always enclosed in a bracket. But that polyatomic, first of all you have to enclose it in bracket, and then you have to write in the subscript the number of atoms of the polyatomic ion. That means like you are having calcium hydroxide, so we know that hydroxide is a polyatomic ion, hydroxide is a radical, so we wrote calcium Ca, then for hydroxide we have kept hydroxide, we have enclosed hydroxide in the brackets, and then we write the number of atoms, that is 2. So this 2 is for oxygen as well as for hydrogen. Same goes with aluminum sulfate. You have Al2 aluminum, then sulfate, polyatomic ion is sulfate, so that is why it's enclosed in brackets, and then you have to write the number of atoms. So this is how you write the polyatomic ions. in a compound. Now the next thing to discuss about the molecular compounds, for that purpose you need to know about the electronegativity of an element. Now, what is electronegativity? It is the ability of an atom to pull, to attract the shared electrons of a bond towards it. That is the electronegativity of an element. And you know that the non-metals are the electronegatives because they have the ability to attract, to pull the electrons towards their self, towards itself. So basically non-metals are the electronegative. Now why we need to study here electronegativity? Because it happens that molecular compounds are formed by the combination between two different non-metal elements. It means it is possible that your compound is having in your compound there is a combination of two different non-metal elements. So while writing the formula of a molecular compound of having two different non-metal elements, then you have to write the less electronegative element first, that means on the left side, and then the more electronegativity negative element comes. That means less electronegative comes first and more electronegative comes next. So this is how you write the molecular formula for the compound having two different non-metal elements. Suppose here you are having hydrogen and chlorine. That means hydrogen chloride, or you can say hydrochloric acid also. This is a kind of an acid. Now see, hydrogen is also a kind of a non-metal and chlorine is also a non-metal. Now what happens here? You have to write the less electronegative first. So in hydrogen and chlorine, hydrogen is having the electronegativity of almost 2.1 and chlorine is having something 3. So see, hydrogen is having less electronegative. Hydrogen has a less ability to attract the shared electrons. So less electronegative comes first. That is why we have written hydrogen first, then chlorine. In case of hydrogen sulfide, again you can see here, yeah, remember this is sulfur but it's changed to sulfide because I told you here that whenever you are writing non-metals, their name changes, their name is replaced by IDE letters. Okay, so this is hydrogen sulfide and hydrogen is less electronegative than sulfur, so that is why hydrogen is written first, then comes sulfur. So we are having different electronegativity for elements. So the most electronegative is fluorine, then we are having oxygen, then we are having chlorine, and it goes so on. So always write the lesser electronegative first and the more electronegative comes later. Now let us write the chemical formula for compounds. For instance, we are having sodium oxide. First of all, you need to write the symbols. So write the symbol for sodium, that is Na, and for oxide means oxygen, so that is O. Then the next step is to write the valency of these elements. So the valency of sodium is 1 positive 1 and the valency of oxygen is 2 negative. So now cross over the valencies of sodium and oxygen atoms. So see here, with sodium atom, we have the valency of 1 positive. So this 1 positive will be written with oxygen and this 2 negative will be written with sodium. So we will get Na with 2 with it, so Na2, and then oxygen with 1 with it. But we don't need to write 1 here, so it's understood 1 is there. So we get the formula of Na2O. So see here, when you are writing the formula, you don't need to write the signs like positive, negative. You don't need to write the charges of the ions. You just need to write the number of atoms. So this is how you can write down the formula. You can find out the formula of a compound. Now another compound is aluminum sulfate. So first of all, write down the elements that are present in this compound. That is aluminum and sulfate. Now see, aluminum is a single ion, but sulfate is a compound ion. That is a polyatomic ion. Now the valency for aluminum is 3 positive and the valency for sulfate is 2 negative. Now cross over the valencies. So you will write 2 with aluminum. So you will get Al2 and 3 with sulfate. So see, the polyatomic ion is enclosed in brackets as we discussed in the rule, and then you have to write the 3. So this is the formula for aluminum sulfate. Suppose you are having magnesium chloride. Again, first you have to write the symbol for magnesium and chlorine. Then you have to write the valencies. The valencies are 2, and chlorine for chlorine's valence is 1. Cross over the valencies, you will get 1 with magnesium, so you don't need to write 1, and 2 with chlorine, so you'll get Cl2. So this is the formula for magnesium chloride, that is MgCl2. And again, see here, magnesium is a metal, so symbol of magnesium comes first, and chloride, that is chlorine, is a non-metal, so its symbol will come later. As I told you that metals come first, non-metals come later. So this is how you can work out the formula for different compounds. Thank you.